So this video is a continuation of Module 9 from the Chemistry 1025 Survival Guide. We're working on problems involving stoichiometry, where we're given an initial quantity of one of the reactants, or possibly one of the products, and our goal is to determine the amount of another chemical in the equation. So this particular problem here, we're starting with 2.50 moles of water, and so I'm going to label 2.50 moles of water. And notice in this case, this happens to be a product in the reaction. And we want to know how many moles of phosphoric acid are required to form this 2.50 moles of water. So the chemical with the numbers, in this case the water, that's going to be your A. That's going to be your A. And what we're trying to find, that's going to be your B. So I stick with the color code here. If the A's are the reds and the B's are the blues, phosphoric acid, that's going to be your B. So we're going to start off with 2.5 moles of water. 2.50 moles of H2O. We want to figure out how water is related to phosphoric acid from the balanced chemical equation. So the mole ratio here is, it's always B over A. So we need 2 phosphoric acids, so 2 moles of H3PO4 over 3 moles of H2O. And that is the correct ratio now between phosphoric acid and water. Check units. Notice the moles of water cancel, leaving us with just moles of phosphoric acid, and that is what we're trying to find. So it's going to be 2.5 times 2, that's 5, over 3, it's going to be 5/3. 5/3 moles of water, of course 5 over 3, that is 1.67. 1.67 moles H3PO4. And that's how we solve that problem there. So this happens to be, I would say, the easiest style of question. We're going from moles of one chemical to moles of another chemical, and we don't have to deal with molecular weight or anything else in the question. Let's take a look at this one. How many grams of sodium phosphate would be formed? All right, that's your question. That's what we're trying to find. That tells you immediately that sodium phosphate, that's going to be your B. That's your B. Sodium phosphate is your B. If 1.75 moles of phosphoric acid were consumed, that's going to be your A. We know the amount of phosphoric acid. My job is to figure out the number of grams, in this case, of sodium phosphate. That's what we're trying to find. We always go from A to B. So we'll start off with 1.75 moles. Okay, so we're starting here in the equation. I don't need the molecular weight of phosphoric acid because I already have moles. I'm going to go from moles of my A, moles of phosphoric acid. Then I'm going to find moles of B. This is B over A. So it's going to be 2 moles of sodium phosphate over 2 moles of phosphoric acid. Just to remind you, these 2's here, these 2 2's came from the 2's in the balanced chemical equation. Alright, now we need to figure out the amount of grams. So now we're here. I want to convert that to grams, meaning now I need the molecular times, multiply by the molecular weight of sodium phosphate. How many grams of sodium phosphate? That's what we have to find the molecular weight of. Now the number down here in the bottom, that's going to be just 1 mole. 1 mole of Na3PO4. Now to find the molecular weight, we're going to need the periodic table. So sodium is 22.99. 22.99, that's 1 sodium. I have to multiply that by 3. Let's see, phosphorus is 30.97. That's phosphorus, and I have 4 O, so it's 4 times 16. 4 times 16. So those numbers I have to worry about. So 3 times 22.99 plus 30.97 plus 4 times 16, that is 163.94. Check sig figs, check units. Let's see, moles of phosphoric acid cancel, moles of sodium phosphate cancel. That gives us now grams of sodium phosphate, which matches what we're trying to find. Sig figs, we've got 3 sig figs here. That's how many sig figs our answers are going to have. 1.75 times 163.94. The 2's are going to cancel out. So we get 287 grams Na3PO4. Okay, and that's how we do that question. How many liters of CO2 gas at STP will be formed? That's your question. That tells you now that your B has to be CO2. From 1.75 moles of phosphoric acid. That's your A. That's got the numbers. The numbers have the A's. Question mark is always the B. So 1.75 moles of H3PO4. So starting here, we're going to go from moles of phosphoric acid. Now we're going to convert that into moles of my B. We're going to find moles of CO2. And then we're going to go from moles of CO2 that way to find liters of CO2 at STP. This is where I need to use the 22.414 to do that. So the mole ratio here is, again, B over A is 3 on top, 2 in the bottom. 3 moles CO2, 2 moles H3PO4. Remember, it's always B over A. Check units. I notice a moles of phosphoric acid on top means moles of phosphoric acid go on the bottom. Alright. Since I'm trying to find liters of CO2, first of all, keep in mind that has to be a gas. If it's not a gas, you can't do this. The conversion for this is every 1 mole of CO2, that is the 22.414 liters. Moles of CO2 cancel. So 1.75 times 3 divided by 2. Notice we multiply by 3 and divide by 2. Then times 22.414 equals. And that would be to 3 sig figs. 3 sig figs is 58.8 liters CO2. And there we go. How many moles of phosphoric acid would be reacted? Alright, so now that's going to be our B. That's our question. So phosphoric acid is B. With 162.5 grams of sodium carbonate. That's your A. So again, your question is always your B. The number, the reactant or molecule, involved in the problem, which has the numbers with it, that's going to be your A. So now we're starting off with grams of sodium carbonate. We're going to find moles of sodium carbonate, find moles of my B, my phosphoric acid, and that's where we're going to stop. Once I find moles, so I do not need any of this other stuff. So 162.5 grams Na2CO3. Now we have to check the periodic table and find the molecular weight of sodium carbonate. See, so sodium is 22.99. That's sodium. I have to multiply that by 2. Carbon is 12.01. And oxygen will be 3 times 16. Alright, so 22.99 times 2. That's 45.98. 16 times 3. That is 48. So add these numbers together, that'll tell us the molecular weight of sodium carbonate. 45.98 plus 12.01, only one carbon, plus 48, that is 105.99. So 1 mole Na2CO3, notice grams on top means grams go on the bottom, 105.99. Okay. That's grams. All right. That makes the that'll make the units grams of sodium carbonate cancel out. Now the mole ratio again is B over A. So it's 2 moles of phosphoric acid over 3 moles of sodium carbonate. So moles of sodium carbonate will cancel. B over A. Now the question said find how many moles. That was our question. So now that we have moles here, we stop. So again, I do not need to find the mass or volume or anything of that nature. So I'll do the calculation. 162.5. Divide that by 105.99 times 2 divided by 3. The 4 sig figs. 1.022 moles H3PO4. That's how we solve that problem. How many grams of sodium phosphate would be formed if 73.1 grams of sodium carbonate are consumed? So what's the question? Well, we're trying to find grams of sodium carbonate. That's our B. Sorry, sodium phosphate. Sodium phosphate is going to be our B. That's our B. And we used sodium carbonate. That's going to be our A. So this problem is going to be for mass of A, find moles of A, find moles of B, and finally we're going to end the problem finding grams of B. Okay, so start off with 73.1 grams of Na2CO3. So I need to find now the molecular weight of that. Let's see, we used sodium carbonate from the previous problem was 105.99, so that's not going to change. 105.99. Oops. So 105.99 grams of Na2CO3, that is 1 mole of Na2CO3. Now the mole ratio. Convert moles of A to moles of B. The ratio in this case is 2 moles of B, 2 moles of sodium phosphate. Over 3 moles Na2CO3. So now moles cancel. Now our goal here is to find number of grams of sodium phosphate. For this now I need the molecular weight of sodium phosphate. So 1 mole of Na3PO4. I think we used sodium phosphate in our prior example. Let me check. Sodium phosphate was 163.94. That's the molecular weight. 163.94. grams. Na3PO4. So we'll cancel that off. So if there's ever a test question where it says show your work, this is the kind of work I want to see. Alright, so 73.1, divide that by 105.99 times 2, divided by 3, times 163.94. That gives us 75.4, 3 sig figs, 75.4 grams Na3PO4. And that's how we do that one. How many liters of CO2 gas STP would be formed along with 85 grams of sodium phosphate? So in this question here, we're taking some quantity of sodium carbonate and some quantity of phosphoric acid, call it Y. We're reacting them together, and we're saying along the way we made 85 grams of sodium phosphate. And our goal here is now to find the volume of CO2. That we don't know. That's a question mark. So I don't care about the masses of sodium carbonate or phosphoric acid. All I care about is the two reactants and two products in this question. So my A in this case is going to be sodium phosphate, and my B in this case is going to be the CO2. Let's compare those two. .85 grams Na3PO4. We have to convert grams to moles. 1 mole Na3PO4. We know that sodium phosphate is a 163.94 as a molecular weight. 16394. 163.94 grams Na3PO4. Oops. Cross off the units. Cross off, cross off. So now we have moles of sodium phosphate. The mole ratio will get B over A. So CO2 is 3. 3 moles of CO2 over 2 moles of Na3PO4. So we'll cross those off. As long as the units cancel, you're most likely doing the problem correctly. Now our goal here now is to find the volume of gas at STP. So 1 mole of CO2 is 22.414 liters of CO2. 85 divide 163.94 times 3 divided by 2 times 22.414, and that is now to 3 sig figs, 17.4. So we get 17.4 liters CO2 for that one. Alright, so the next question's a little bit different. This one gets an idea of something called percent yield, something I've not mentioned yet. So percent yield, this is equal to the actual yield divided by the theoretical yield times 100. So actual yield, this is what you got on the balance. Got on the balance at the end of the experiment. It's what you actually have in front of you. You do the experiment, you collect your product, you purify it, you analyze it, you weigh it, you get this some number. The theoretical yield, this is what the calculator says. It's what the calculator says is what you're supposed to get. So all these other problems you've been doing involve theoretical yields. How many liters of CO2 gas will be formed? That's a theoretical yield. We didn't actually do the experiment. In order to get an actual yield, you must actually do the experiment, collect your sample, and weigh it. Theoretical yield, you can do. Theoretical yields are just textbook questions. It's what the textbook says you should get. So if you read this question here, it says, what is the percent yield of sodium phosphate if 160 grams is reacted to form 96 grams of sodium phosphate? This number here is 96 grams. That is the actual yield. It tells you what you actually obtained at the end of the experiment. So that's going to go in the numerator. We need to calculate the theoretical yield based off 160 grams of phosphoric acid and then the balanced equation. So 160 grams it's 160 of H3PO4. So we're going to follow the same flow chart as before. We know the mass in grams of phosphoric acid. We're going to find the moles of phosphoric acid using the molecular weight, the mole ratio in the problem. Now, which are A and which are B? Or A gets the numbers, so phosphoric acid is our A. Find the percent yield of sodium phosphate. That's our B. Okay, so I need to find the molecular weight of phosphoric acid. I think we used that earlier in an earlier question. Maybe we didn't. Okay, we'll look it up. So hydrogen is 1.01, so times 3. Phosphorus was 30.97. And then we have 4 O's. They have oxygen is 16 times 4. So 3.03, 30.97, and 16 times 4, it should be 64. It's 64. So 64 plus 30.97 plus 3.03, that gives us a total of 98 even. So 98.00 grams per 1 mole H3PO4. H3PO4. So now it's B over A. A mole ratio is B over A. So we're trying to find percent yield of sodium phosphate. So it's going to be 2 over 2. 2 moles of sodium phosphate over 2 moles of phosphoric acid. Alright, now we're trying to find the yield of this. Find the yield, we're talking about grams. So now I need the molecular weight of sodium phosphate. So 1 mole Na3PO4, and I believe that was 160 something. Sodium phosphate 163.94. Alright, whatever you get for this calculation, that is the theoretical yield. So 160, divide that by 98, times 163.94, and that's 267. 267.7 to 4 sig figs. We got 4 sig figs here. Grams of Na3PO4. So this is the theoretical yield. So percent yield. That's the actual yield. Now we're told the actual yield was 96 grams. 96.0 grams. We'll divide that by 267.7 grams times 100. And they'll be around the final answer down to 3 sig figs. 96.0's got 3 sig figs, so we keep 3 sig figs. 96. Divide that by 267.7, and that gives us, times 100, 35.9 percent. So this is now the percent yield for this experiment.